My pleasure to welcome Judith, who's going to give us a presentation on architecture for orchestrating containers in cloud federations. Please go ahead.
Okay, thank you very much. Thank you, Somaya, for a very warm presentation. And really, I'm also interested on cloud federation formation, which is a bit similar with your research topic. So I hope I will have your contact to maybe for further discussion and for having some question and answer session. So thank you. So hello everyone and all researchers around the world. So first of all, I would like to thank the GeekCon 2021 organizers for accepting our paper as a work in progress paper. So let me introduce myself. My name is Gebrealif and I am a PhD student in Seoul National University. And with me, I have my partner, Mohammed Mubarakot. He's also a PhD candidate in the same university, and Professor Donald Mann and Professor Bernard Eger. So I'm going to present our working progress paper called Architecture for Orchestrating Containers in Cloud Federation. Yeah, so on today's presentation, I would like to cover these topics, starting by explaining the two key concepts of this paper. So let me just start with the introduction. Yeah. So the first key concept that we would like to focus on this paper is cloud federation. So according to a National Institute of Standard and Technology definition, cloud federation is virtual security in a collaboration context that is not necessarily owned by one user or organization. And it also it extends the use of cloud resource beyond the provider's own resource and enhance a collaboration between cloud service providers based on the federation level agreement in addition with service level agreement. So the next key concept of this research is containerization. So in the traditional virtualization, as you see in the left side picture, each virtual machine contains a guest operating system, a virtual copy of hardware that the operating required to run, and an application and its associated libraries and their dependencies. So virtual machine with a different operating system can run on the same virtual servers. So in the contrary, instead of virtualizing the underlying hardware, container virtualization or virtualize the operating system, as you see in the left side diagram. That means each individual containers contain only the application and its libraries and dependencies. So containers are small, fast, and portable because unlike virtual machines, unlike the traditional virtual machines, containers do not need to include a guest operating system in every instance. That makes it fast and easy to portable from one cloud service provider to another. So the key challenge that we would like to address in this paper is scalability, resource utilization, and portability. So scalability, when we talk about scalability, it is one of the key challenges in cloud computing that was addressed by Cloud Federation. However, dynamic or automatic scalable capability is still a challenge for Cloud Federation environment. And also, in addition to this, resource utilization is also another challenge. Since certain cloud service provider might experience a lack of resources, while at the same time other cloud service provider post extra resources that are not fully utilized. Then on the top of this, it's also important to guarantee portability and compatibility of the application between cloud providers. So these are the key challenges that we'd like to cover in this paper. Yeah, so in order to overcome the challenge in the previous slides, we explored literatures to see the applications of container in Cloud Federation. However, we identified that there is a gap on applying container orchestration in Cloud Federation that allows the Federation environment to create high portability, resource utilization, and scalability of application deployment. Yeah. So based on this initial point, we try to explore literatures to look for some of the existing technologies that applied the container orchestration. So as you see in this table, we present you various resource orchestration solution in the market, which are already implemented in the multi-cloud environment. From all these technologies, only Mikado, which is indicated here, is a highly customizable multi-cloud orchestration, and auto-scaling framework is addressed by the container orchestration. So that means it's only for a multi-cloud environment. And hence, there are many applications of container orchestration in a multi-cloud environment. However, none of them extends the application of this containerization or container orchestration in Cloud Federation. So to utilize containerization technology in Cloud Federation, the management of container requires, or the requirements for the architecture need to have first to have a control over container cluster deployed on different cloud service providers. It requires, in order to support the orchestration lifecycle of containers, that is create, deploy, upload, or scale, and also it need to it also need to help to enhancing the monitoring, and also it need to have a regular monitoring container instance running across different cloud service providers. It need to check their health status and take necessary actions, and also it need to have elastic resource provisioning. So that the load and usage of resource can efficiently be managed and calculated. And also need to have a component that allows a secure management of customer instance running across the federation. So fulfilling these requirements enable a provider agnostic and a successful orchestration of container across Cloud Federation, and also a clear picture to a customer on where their containers are running. And moreover, it also facilitates monitoring and billing, and also managing a container cluster and their instance running across federation. So based on the reviewed literature, the National Institute of Standard and Technology reference architecture is well suited to apply a container orchestration for achieving a system portability. So given this, NIST define 4 components in the Cloud Federation reference architecture as used in the figure. Because of the time limitation, I'm not going to discuss about each components and their functionalities, but if you are interested to see the detail of each components, here is the reference, so you can look, take a look and get the detailed information about each components and their functionalities. So in this paper, we adopted this NIST architecture for a centralized topology arrangement and focused on 2 subcomponent enhancement, namely the resource manager and the resource manager and the federation carrier components. So to meet our objective and requirement, we propose 2 new subcomponents to integrate these new 2 subcomponents to integrate in one in the resource manager subcomponent and one in the federation carrier. So the proposed 2 subcomponents are namely resource identifier to integrate in under the resource manager components, and the second one is a container orchestrator to integrate it under the federation carrier component. So this resource identifier is it's a subcomponent to identify a resource and enhance the resource manager activities. And also the container orchestrator is a proposed subcomponent that facilitates the orchestration of containers across federation. So let's see the algorithm of these two subcomponents in the next slide. So for the first proposed component, which is a resource identifier, the first assumption is that the resource information and user informations are already provided. That means resource information means that the CSP, the cloud service providers offer n different types of resource, such as it might be computer resource or storage resource or network resource. So we are assuming that they are providing n different types of resources. And the capacity of these resources are represented as a vector C, as you see in the slide. So the second, and given this, the unit cost of each resource that we represented in the C1, C2 until Cn is also given, and it's represented in the vector P. So yeah. So as you see in the P, it's also have a vector P1, P2 until Pn. That means P1 represents the unit price of the resource C1. P2 represents the unit price of resource C2. So the second assumption is that the user information is also provided. So the requirements of the user is represented with a small r, and the price threshold is also represented by T. So the overall submission of the information of the user, the specific user, is represented by capital R, which contains the small r and small t. So this is the algorithm of the resource identifier subcomponents. So as I already mentioned in the previous slides, in the beginning, the assumption is that the resource information and user information is provided. So based on these two informations, the aim of this component is to determine the appropriate cloud service provider for handling the required resource requests. So this component is initialized in the beginning. It initialized when the client send request for extra resource along with the price that the client is willing to pay. Then once this information is provided or received, then this component contacts or requests all CSPs for their current resource status. And once the current resource of all cloud service providers identified, the information from log file is checked in order to identify if the same request was made or executed before or not. So this step is necessary to save computation power if the information is available in the log file, and if the status of the selected CSP from the previous task is available. Then this component returns the cloud service information, the cloud service provider information to the container orchestrator. Otherwise, the component use equation 1, which I didn't include it here, but you can find it in the paper. So just to compute, it uses this equation 1 to compute and predict the possible unit price that cloud service provider can provide based on the predicted unit price from the user. Then after the unit price is predicted and the list of cloud service provider which is delivered their service based on the price is identified, then the component select the optimal cloud service provider by evaluating the nearest cloud service provider to handle the task. Then finally, the resource identifier returns the selected cloud service provider information based on the previous evaluation methods and updates its log file or log database. So the second component is container orchestrator to facilitate orchestration of container across the federation. So since Cloud Federation deals with a completely separated entity, managing container cluster and updating of master nodes that typically deal to rebuilding the container image can be challenging from many aspects. So to overcome such problems, the Federation Container Orchestrator takes a full control of container cluster to deploy across a federation member and manage their life cycle. So to see the proposed algorithm for container orchestration orchestrator components, the container orchestrator is also initialized by the client request. So once the request is received, this component check if the request is made from for the first time or not. Then if the request is made for the first time, the proposed component receive a container image from the requester cloud service provider. But if the request is not issued for the first time, that means the component will check if the container image is different from the one in the container repository stored during the first request or not. Then once the container image have been received, either from the master node or from the repository, then the communication can be established with the cloud service provider, which means from the selected cloud service provider by the resource identifier. Then the application will be sent to that specific cloud service provider. So the whole figure visualize the whole operation of the container orchestrator component. So yeah, this is what we have as a work in progress paper. So to conclude our presentation, in this paper, we presented a container orchestration architecture in a centralized or broker topology of federation environment. So by enhancing the NIST reference architecture, we add two subcomponents called resource identifier and container orchestrator. These two subcomponents track the available resource in the federation in the federated cloud and use this information to prioritize and decide which federation member shall run the container. So therefore, the overall advantage of the extended architecture is to minimize the resource utilization through increasing the resource flexibility and efficient service delivery, and also to enhance portability, scalability, and interoperability of application in the cloud federation environment. So for further future work, we would like to evaluate and see the proper simulation tool then in order to analyze and evaluate the proposed architecture by implementing a linear regression technique for resource identification. So that's all what we have. Thank you very much. So if you have any questions, comment, or feedback, you are most welcome.
Thank you, Yodit. Thank you for your presentation. We have maybe a couple of minutes for questions. Anyone? You can raise your hand or you can just step in. Let me check my screen. Right. So maybe again, I can ask a question just to start. So Yodit, this idea of orchestration of containers over a federation certainly is very attractive. I would like basically to ask you on the aspect of portability, right? So especially in the case of your architecture, it's a proposed architecture. Again, this is work in progress. We have not evaluated yet. So where do you see again this challenge in terms of portability? The reason is that in the context of virtual machines, especially if you move virtual machines in a federation, you will have obviously to deal with the configuration of the virtual machines themselves. We refer to this as contextualization. And if you say migrate a virtual machine to a different provider, you would have to recontextualize. So that's an automatic configuration. And that will somehow support the aspect of portability and interoperability. So what will be, again, what will be the challenge here in terms of container orchestrations?
In the cloud federation, I think container orchestration is actually it's a very beautiful thing that we can implement in cloud federation, not only because it facilitates portability, because it's also easy to handle, especially since the cloud federation is integrating so many heterogeneous infrastructures. So that's also one of the challenge that we are not like or tackling, or we are challenging the implementing a virtual machine. So by implementing containers, this heterogeneous infrastructure might be integrated and work together, like with no, or of course not with no, but with a little challenge, because by itself the container, it can virtualize the operating system. It contains all the necessary deployments. So it's also invented to just to be integrated, or to be worked on the various heterogeneous infrastructure. So that is one of the challenge that we cannot, or very challenging to apply virtualization. But in terms of container in terms of container, it's really a good technology to apply on Cloud Federation, if I answer your question.
Yeah, definitely. Yeah, definitely. So I'll look forward to your evaluation, and maybe you can present your results in GeekOn 2022.
Of course,
Thank
absolutely.
you. Richard,
Okay.
Richard has a question.
Okay, Richard.
Yes, good evening, everyone. Judith, I have a question regarding your literature review. You have shown some multi-cloud technology which apply the containerization term in the platform. However, I can't see the difference between Cloud Federation and multi-cloud. So would you explain your motivation for doing this topic regarding to Cloud Federation, please?
Okay, Richard, thank you very much for asking these questions. Actually, there are many differences between Cloud Federation and multi-cloud. Of course, some literatures used this Cloud Federation alternatively with a multi-cloud, but they are totally different. The difference is not only in terms of their business model context, but also they are different in terms of their portfolio, in terms of the providers, in terms of their connection, user provider, even in terms of their service level agreement and provisioning, and also scheduling. Also, they are so much different from each other. So, for instance, if we see the service level between these two entities, and a multi-cloud has a multiple service level agreement. That means the agreement is various based on the number of the providers that they are working with. But however, in the case of Cloud Federation, the agreement is single, and which is the agreement with that each cloud service provider agreed or having with the central entity in the central broker, of course. So the agreement will be a single. But when I come to our topic, which I mean the difference, which leads us to our topic, is that there is a provisioning and scheduling difference between these two entities. One is in the provisioning in the multi-cloud customer. Or in the multi-cloud, yeah, the customer or the representative service might do the automation or the provisioning, provisioning part. But in the case of Cloud Federation, the home cloud, or in our case, maybe the central broker, which integrate all the cloud service provider will do the integration, the provision. So that's also one difference between these two. And the other one is regarding application scheduling. So in the multi-cloud, the application might be executed in different cloud service providers, which might located in different continents or locations. So because of this, the multi-cloud API will be various, and which is very difficult to even for the client of the cloud, just difficult to manage and to trace where their application is executed. But in the case of Cloud Federation, since we have a single scheduling, like the central one or the home cloud do the scheduling part, so the client can easily see or track where the application is executed. So these 2 points are directly related to our topics that makes the multi-cloud and Cloud Federation different.
Okay, thank you, Judith.
Thank you.
Okay. Thank you for this. No more question. You have a question? Oh, go ahead. Yes. Go ahead.
Thank you for your presentation. It seems that it's a promising architecture. I have one question in regards to the orchestration. Is it centralized orchestration or is it going to be a distributed?
Yeah, actually, we are thinking the centralized one. I don't know if, okay, let me try to, let me share my screen again. I think it's, yeah.
You're already sharing your screen. Just
Oh, sorry.
Yeah, you are. Yeah, we are
Okay,
seeing.
good.
We are in the deep of the sea now. Not
No,
anymore.
can you see my screen now? The architecture. So as you see, this part is the federation layer is the central part. So it's the central topology. That means that there is a central entity in the central part that integrates all service providers that you see here. All the service provider that makes them integrate and work together. So it's definitely the centralized architecture.
It's a centralized one.
Thank you so much.
Thank you.
Right. Okay. So thank you, Judith, for your presentation. I'm going